to start the modeling part. So here I am selecting a linear regression model. So guys, we know that we are going to do regression, right? Because our target is a number. Now there are a lot of algorithms which are available. Linear regression is one such model. So now you know we are doing regression, right? But for regression, there are multiple algorithms or let's say models. Now which model to use? So the most important and the simplest algorithm or the model we have is linear regression model, guys. Then other than linear regression, we have polynomial regression. I will explain you the differences. We have ridge and lasso regression. We have the most famous model, which is a decision tree. Okay. And likewise, there are multiple models like KNN, K nearest neighbors, and so on. So we will talk about them. But as a beginner, you should start with linear regression. Then there is a advanced form of regression known as polynomial. These are all dependent upon the mathematical equation, guys. Remember, for every model, the mathematical equation will be different. We will be seeing into all those equations. What will be the equation for ridge and lasso regression? A decision tree, there is not any equation as such. It's just a tree. We will talk about it's going to create you binary trees. How that happens. KNN is K nearest neighbors. We will talk about that. But yeah, high level, these are some very common models. There are advanced models also, but these 5 are the most common models for regression. So we will start with linear regression today and see what it is. So for linear regression, I am using sklearn's package again. This time the sub package is linear models. I am using linear regression. So far, the mathematical equation I was teaching you, that was for the linear regression only, guys. This y equals to m of x plus c. This equation was the equation of linear regression. Okay. This is a regression algorithm which uses a linear equation. Simple. Why this word is, it's a regression algorithm which uses a linear equation. So what is this? In the field of maths, this is a linear equation of degree 1. There is no polynomial equation. So when we'll talk about polynomial regression, it will become like x square, x cube, y is equal to m of x square plus c, or y is equal to m of x cube plus c. So that will be polynomial equation. We will talk later. But today our objective is the linear equation of the degree 1. So if you have x1, you have x2, all of these variables, right? The features have degree 1. So that is what is your linear equation. So now this is my linear regression model. Now the objective of training this model is to train this equation and find the best value of m1 and m2. And if there is an intercept slope. Okay. That is what is the objective. So let's deep dive. So see, there is ridge also, lasso also, elastic net also. There is this decision tree regressor also. We will talk about all these things later, but today our objective is linear regression. So what I'm doing, I'm creating an object of linear regression class by calling this constructor. So in the field of oops, you guys are aware, right? That, okay, this is a class, I'm calling its constructor, default constructor. But I am calling a default constructor here. If you want, you can call the constructor with different signature. How? Just do, guys, always do it this way. Uh, question mark of the class name. So from the sklearn's linear models, I'm importing the linear regression class. You should always do question mark to look at the entire signature of linear regression. So what all things it can accept. Okay. In this case, this linear regression model is using something known as ordinary least squares method. We will talk about that again, but this is our linear regression model. And these are the input parameters it can take. You can go through the entire documentation as per your interest, but the output from here, you will see the coefficients. The output from the model will be those M1 and M2. These are the coefficients or the weights. I will show you. You will also see that C, the intercept. which is 3 in this case. This is the object. On this object, I am calling the training method. So guys, in some programming language like R, we have the train method for training. Here in Python, we have a fit. Fitting means you are fitting the machine learning model on the training data. So this is the training cycle. Okay, guys, this is the training step. You are training the model. So this is your linear regression model. You are training it. Training it or on what? The training data. But now you see the train X and train Y. What is this? So the train X contains all the features and train Y contains the target. So the data which you had here, what I did, guys, this is the Python's standard. You have to do it. Here, what I'm doing, see, in this data frame, training data frame, only X is there. X means features. Okay, all the features. And on the training Y, I only have the target, expenses column. Okay, and then I am doing the training. The model will be trained on this data. Once the model is trained, guys, the equation is ready. So this is the intercept, the C value, and this is the coefficient, the weight value. So see, let me show you how many input features you had. 1, 2, 3, 4, 5, 6, 6 input features. So for every feature, let me copy these. Okay. So these are your features that went into the model, right? And this, once the model is trained, these are the weights, the coefficients that model has trained on. So look at these. And now let's try to understand this. See, this was one of the input feature. This was second, third, fourth, fifth, and sixth, right? So what is this output? This is the weight W1, which is like W1 times of age. This is weight W2, W3, this is W4, this is W5, this is W6. And how many features you have? First, second, third, fourth, fifth, sixth. So for every feature, this is their corresponding weight. So now if I ask you which of these is taking the biggest role in deciding the loan amount, so that will be decided by the weight. So look at the maximum weight, 251, 305, this one, right? It is having value
Okay.
23580, means smoking. So if someone is a smoker, their insurance value will be spiked highly. See what a high weight it is. But you also see some negative values. Negative value, again, this also impacts the target, but in a negative way. What that means is, if you are calculating Y, so if someone is a smoker, so his premium is increasing, right? But if I look at 1, 2, 3, 4, let's say this column, which is the gender. So in this case, minus 39 of this value. So let's say you have gender 0 and 1. There will be two values, right? So if 0 denotes male and 1 denotes female. So if for male, this is 0. So gender has no impact. Okay, means your loan amount, your being a male will not play any role. But if you are a female, uh, loan amount will decrease by 39, because for gender you have only two values, 0 and 1. So if you are a male, your loan amount will not be increased or decreased. But if you are a female, you will be given some flexibility. Your loan will be decreased, right? That's how it happens. Similarly, based on the region, if you are living in a particular region, it can happen that uh, your loan amounts are going down based on the region. Okay, that's how you need to understand the negative values. Any question?
Yes, Rahul. So seen that it's trained and identify the weightage, right? But our data which we use here, it is all encoded, especially in I'm talking about the region. So we generated a sequence of all region 1, 2, 3, 4, 5, 6, right?
Yes.
Now, and that time we were using different library. And this weightage generation is happening with linear regression libraries. So how this model know that one is what region, two is what region? It might be, I mean, if
Very good.
because by default it is assigning some number, right? So let's say if six number assigned to Delhi, right? But how this model know six is Delhi?
Okay, excellent question. So to answer it at a very high level, model does not worry whether it is Delhi or Mumbai. Model has no role with the name of the city, whether it is Delhi, Mumbai, or whether it is let's say Uttarakhand. For model, everything is a number. So model, what it know is that okay, this three is some number. It does not matter what it denotes. But when model is learning, it is learning a pattern. It is learning based on these numbers. It is deducing something, and already it had the target values in the training phase, right? So model, what
Right,
model
right,
learns is, oh, whenever there was a region 3, the insurance premium was always less. But whenever the region was 1, the insurance was high. So model knows whenever the value is 1, it has to be high. Whenever it is 3, it has to be low. So that's why it is giving you a negative values. Let's say negative 2. So now negative 2 is your weight associated to this. Now when it is, let's say 1, so your premium is decreased by a unitary value of -2. But whenever it is 4, let's say, it is decreased by -8, means you are really living in a very good area because your loan is getting decreased by -8 amount. You are given more discount, right? But model has no role to see what 3 is, what 4 is. It is just learning the
got it.
pattern of the numbers. But that's a very good and important thing, because consider same happening with gender also, smoker also. A model is only looking at the binary values or the whole numbers, not whether it is yes or no. Uh, Even there is one more thing which people normally adds is, along with smoker, how many cigarettes they smoke on an average in a day. That is also one of the important numerical column,
Yes,
which is
yes.
not here. But yeah, even how much hours you exercise in a day, right? These are some of the things. Alcohol consumption. These are the things which are also added.
Any family history. So
Yes.
some of the, yeah.
Okay, so I hope you guys are now able to understand that what the model is doing. With every input, it is assigning a weight, some positive weights, some negative, some high weights, some low weights. How all these things are actually now going to play a role in your mathematical equation. So let's look at this. So now, once the model is trained, guys, your equation is built. Now, anyone who knows this equation can input the values and get you the output, right? So ultimately, your work is done here. Your equation is built, right? You know the values of m's. What is unknown is x1, right? Let's say you know m2. What is unknown is, let's say, x2. So now, if you know x1, x2, you just substitute those values here. Like, you get the y. It's any mathematical computation, right? So you don't need any fancy system. It's just now putting the incoming values and getting the output into this equation. So our equation is built, guys. Your intercept is also there, a negative intercept. Finally, we come into the testing phase where we are on the same machine learning object. We are using now the prediction method, predict method, and see, we are only passing the test data, but with only x. Remember, we were discussing, we are not exposing our y. From the test data, we are not exposing the target values, only the x, which is the features, right? X denotes your feature set, and y denotes your target, right? So let me just comment these. So from the test data, we are passing all the x here. And guys, these are your predicted values. So for the data, whatever we had, the test data, these are the predicted values for every person in the test data. And what I will do now, this is my predicted output. But see, I was explaining you, error is actual minus predicted. So what I am doing, actual values were the y values, and subtracting with the predicted values.